And we are live. Welcome to Math with Doug. We are continuing our series of videos about pre-algebra. Getting ready for algebra, practicing a lot of the skills that we use a lot while we do algebra. The dog is going to sit on the armchair and pay attention. She's talking really big about how she already knows everything about algebra, but we'll see at the end of the lesson. I'm going to give her a little test. I know that if you were the one who had to stand up here with chalk in your paw, you would probably freeze. It would be stage fright, wouldn't it? Yes, overconfident dog. Okay, down you go. Lie down. Get comfy. Yeah, you're good at that. You might not be as good at algebra as you think, but you're very good at being comfortable. Dogs are good at that. Okay, so this is Hearts, soccer team from Edinburgh in Scotland. It is a beautiful spring day. It is warm. I just mowed the lawn. It's allergy season. My eyes are itchy, and a great way to aggravate your allergies, tree pollen allergies, is to mow a lawn where you stir up any pollen that's around. So that's how I feel. But being down here in the comfort of a math environment will probably help me get over this little allergy attack. Let's hope so. Okay, so let's get into the math. As usual, I have a bunch of questions ready, but I didn't put all of the details you need because I know what students are like. They will solve every single one of these questions while I'm doing my little intro here, and then the students will think I'm pretty boring because they'll already know the answers to everything. So in every one of these 6 questions I made, there is something missing, and I will fill it in when I'm ready. For these ones, well, all the information's there. It's just that we don't know what the question is. I haven't asked the question. So yes, us teachers are full of tricks. Let's get into it. We are practicing first this thing here, combining like terms. Very important. We actually already did some examples of that in the last lesson. Now we're going to do a little more. We're going to introduce a few extra little tidbits. So I just need my notes so that I can put in the missing bits. This is 4a plus 2a plus 6. I'm very confused, and it's because my page of notes is upside down. So that's what I need. Okay, 4a plus 2a plus 6 minus 2. That's all that was missing, a 2. Okay, we're combining like terms. So we see that the 4a and the 2a are like terms because they both have an a. And they're the same. They both have just a. You don't have one of them with an a squared while the other one has an a, because those would not be like terms. These are like terms. 4a plus 2a, and then these are also like terms. These two constant terms, they're numbers that don't have variables at all. So we're allowed to combine like terms. And 4a plus 2a gives us 6a, not too tough. And then plus 6 minus 2, plus 6 minus 2 combines to give me plus 4. Done. The first example already done. We feel smart. Okay, second example. We have negative 4x plus 8x minus something, and the something is a 4. And it's the negative 4x and the 8x that are like terms, and the minus 4 is not like the others. Negative 4x plus 8x, we are applying our laws of adding and subtracting integers. When we do this, negative 4x plus 8x is equal to positive 4x. And then the minus 4 has nothing to combine with, so I just have to keep a minus 4, and I am finished this example too. Sorry for stepping partially off camera. I want students to be able to see the questions, right? Okay, third one. We have 5x minus 2 plus 6 minus x plus 1. I think I need to use my teacher chair for this one so that I can get down there and be able to write on the chalkboard wall without it being too messy. And I also want to make sure it fits in the video rectangle. Okay, so what are the like terms? We have the 5x and the minus x. They're the like terms. But we also have minus 2 plus 6 plus 1. We have 3 terms that are constant terms that have no variable. Well, we're going to combine like terms. 5x minus x gives me 4x. Minus 2 plus 6 brings me to positive 4, but then plus another one, it's plus 5. 4x plus 5 is the simplified expression. Question 4. Brackets. We knew that was going to happen. We did a review of our PEMDAS for a reason before we got to this stuff, because we still apply the order of operations when we get into this sort of example. And again, something is missing over here, and it is, it's a 5, minus 5. Now we can finish it. So I have to do the parentheses first, but I can't really simplify inside them because they are not like terms. X plus 3, I cannot combine those. One of them has the x, the other one doesn't. So that means that the parentheses are there just so that I can show a multiplication. I am multiplying this 2 by everything that is inside. So 2 times x is equal to 2x, and 2 times 3 is equal to 6. It'll be a positive 6. I still have the minus 5. Now I can combine the 6 and the minus 5. They are like terms. I couldn't do that before because the parentheses, the bracket was stopping me. But now that I've done my multiplication, I don't need the parentheses anymore. 2x plus 6 minus 5. We have plus 6 minus 5. That is going to combine to give us plus 1. We're done. Okay, so having brackets or parentheses does not stop us from being able to do these. We just have to remember to apply the order of operations. Once you learn the order of operations, it just sticks around and always has to be considered. Negative 4 times x plus 2 plus 6. Very similar question. I decided to give several like this because what happens when you multiply across the bracket is different depending on what signs are involved. So I wanted to give several examples with juggling the type of signs that are involved. Where are there negatives? Where are there positives? So again, we cannot simplify inside the parentheses because x plus 2 is 2 terms that are not similar. But we can multiply either of them by negative 4. Negative 4 times x gives negative 4x. Negative 4 times positive 2 gives negative 8. And now we can combine these two like terms. Negative 8 plus 6 combines to minus 2, negative 2. So we have negative 4x minus 2. We are finished that one. The last one of these 6 examples that I put up here is negative 5 times the parentheses plus 7x. Okay, and again, what's inside these parentheses this time is not like terms. We cannot combine them, so they're there for a multiplication. Negative 5 times negative 2x, again, laws of multiplying integers. Negative times a negative is a positive. Negative 5 times negative 2x is positive 10x. And then negative 5 times negative 6, again, will give us a positive answer. It will be positive 30. But we still have to combine it with the plus 7x. Is this going to fit? Just barely. 10x plus 7x are like terms. They will give us 17x. And then the plus 30 just gets carried down and kept because there is no term like it to combine it with. Yes, that fits just barely. Okay, so that's my first 6 examples, but I actually have some more. Where are we here? I have 2 more that I want to do before we move on to this sort of geometry-ish looking thing. But I'm going to erase the first 6 to make room. And I think this is the last time I'm going to need my teacher chair in this lesson, so I'm going to move it out of the way. And of course, very important to hydrate. So I'm going to take a sip of my fizzy water, which is ginger ale flavored fizzy water. That's good. And I think it might not hurt for me to show off my elephant impression. Excuse me. Yes, the allergy attack is calming down. I can feel my eyes becoming less itchy. That's good. Okay, next question. So question 7 and 8 for this section of the lesson. I'll put 7 here. And this one, another one where we're multiplying across a bracket or across parentheses. We have negative 3x multiplied by x minus 5 plus x squared. Okay, so again, the x and the minus 5 are not like terms. We cannot combine them, so they are there to be multiplied by this term here. Negative times a positive gives a negative. 3x times x is going to give me 3x squared, so we have negative 3x squared. Then negative times a negative gives a positive. Negative 3x times negative 5 is positive 15x. And we still have this plus x squared that gets carried down. Now that we have done this multiplication, we have created another term that is like it. Negative 3x squared plus x squared combines to give negative 2x squared. And then I just carry down the plus 15x, and I am finished question 7. Question 8. 2 sets of parentheses. 2 times negative x minus 3. No, it was plus 3. There, fixed it. Minus 4 times x squared minus x. Okay, so what is happening now that was not happening in last week's examples or in some of the earlier examples from this week is we're getting a little bit more of the bracket stuff, the parentheses, multiplication stuff, simplifying within the parentheses as well. And we're also getting multiplying across the parentheses, which is the distribution property. So we're combining some of the things that we have already reviewed, and it's looking more and more algebra-ish. And we are actually brushing up on a lot of skills that we will use when we start doing real algebra problems. Okay, I have 2 sets of parentheses, but I get to this one first when I read from left to right, so I'm going to deal with it first. I cannot combine the terms inside it because they are not similar, but I can multiply both of those terms by the 2. 2 times negative x is negative 2x. 2 times 3 is positive 6. And I like to just copy down the rest of the question and not try to do too much at once. I like to use a little bit of paper when I do these type of problems. But then again, we have this, and we have to deal with this next. But again, what's inside it are not like terms. They both have x this time, but one of them is x squared, the other one is an x that is not squared. So they are not like. So they are there together, so they can both be multiplied by this 4, by this minus 4. Ooh. Have to be careful. The negative 2x plus 6 is just getting copied down. Minus 4 times x squared is minus 4x squared, which is always easy to see. The first thing you multiply inside the parentheses is always easy to see what you're doing, but then the second thing is where mistakes happen. We have minus 4 times minus x. It is a negative times a negative, so it's giving us a positive answer. And 4 times x, of course, is 4x. We have plus 4x. Now I need to still try to combine like terms, and I realize I have an opportunity to do that because these 2 terms on either end are like. They both have just x. This one only has a number, and this one has x squared. So, negative 2x plus 4x is positive 2x. And as I've mentioned before, sometimes in math, we look at this answer, we realize we cannot simplify it further, and we decide whether we want to reorder it. So a common way of reordering it, and I won't have room below, so I'll just write an equal sign and write it over there, is descending powers of x. So the largest power of x is this x squared. We have negative 4x squared, and I can write that first. Then the next power of x is this 2x. It's positive, so I'm writing plus 2x. And finally, it's this 6 that doesn't have an x at all that comes last, plus 6. So these 2 expressions are equivalent. They really mean the same thing. Sometimes it matters that you want to reorder them. Sometimes it doesn't matter so much. But the fact that sometimes it's going to matter means it can be a good habit to be in. Having a trinomial, which is what this is called, in descending powers of x comes in very handy when we move on to some other topics in math that I'm not going to discuss today. But a useful skill to practice. And that's it for all of that style of question. I've used only 1/4 of my hour. That's pretty good. I want to get into some of this geometry-ish stuff. That's what we're doing next. She's pretending to be asleep, but I can see her eyes open just a little bit. She's kind of looking at me. As if she's daring me to put her up in front of the camera and make her teach the pre-algebra lesson. Show off, dog. Okay. I'm going to erase all of this. let's deal with this shape on the top first. Now, I guess we can see that there's some evidence that this is a square. And what I want to do is I want to find the area of the square, but I also would like to find the perimeter of the square. That's what the question is for this shape. Now, how do I know it's a square? I can see it's a quadrilateral. I can see that all of the internal angles are 90 degrees, so it's a rectangle or it's a square. But when I see that I have x as a side length, and then over here I also have x, oh, if they're both labeled x, then whatever x is, they should be equal to each other. And when the side lengths are equal in a square, when perpendicular side lengths are equal in a rectangle, it means it's a square. So I'm applying the area of a square formula, which is this one, side length squared. In this case, the side length is given as x. So it's going to be x squared, and I'm finished. That was fast. So when we want to know the area of a square, we multiply the side length by itself, which I did. But since all we know is that it's x, well, we know that the area has to be x squared. Whatever x is, the area is x squared. That's interesting. The perimeter of a square is the total of the four sides, which we could add together, or we could just multiply the side length by 4. So we could do it either way. If we're adding them together, it's x plus x plus x plus x in this case, which gives me 4x. But of course, if I like to do multiplying by 4, then it kind of happens all by itself really quickly, because the perimeter is 4s, which in this case will be 4x. Same answer. Perimeter is like that for most shapes. Okay, what else can I do? Well, we can try the whole evaluating that when we know what x is, then we're able to plug it in and evaluate the expression. So let's say in this case, x, hey, why don't I even measure it? I'm going to measure x in inches, and that is 10 inches. So if x equals 10, then this expression, x squared, becomes 10 squared, which is equal to 10 times 10, which is equal to 100. And of course, I didn't say what the units are, but yes, I did. I measured it in inches. So therefore, it's going to be 100 square inches this time. But of course, I could change my mind, and I could say this is a scale drawing, and the x is actually 5 feet. And then I would be plugging 5 into the x squared. I would get 25 square feet would be my answer. So it becomes a very flexible situation when you have algebraic expressions given for the side lengths of these shapes. I may as well do the perimeter as well. So therefore, I'll just do the 4x, which is, if the side length is 10 inches, it would be 4 times 10. The perimeter, therefore, would be equal to 40 inches. And I have evaluated both of these geometry, algebraic expressions. It's interesting, all sorts of things that we've been studying lately kind of come together in this little example. And it's fun the way you're able to do that. We're stepping from one topic of math into another every now and then when we feel like it. Okay, I am going to erase the square info, and then we'll do this rectangle. So the area, well, we can see it's a rectangle because we see that visually it's pretty obvious that this side is longer than that side, but we also see that they're labeled as x and x minus 5, which should not be the same number. X cannot be equal to x minus 5, can it? And I'm trying to think of situations where it could be. I don't think so. So therefore, we have evidence that this is a rectangle. Therefore, we're not going to try to use the area of a square formula. We're going to use the area of a rectangle formula, which is base times height. I like to write it like this. Area of, I'm putting RE for rectangle. I just do this to organize myself, especially on a page where I have multiple shapes, so that you can see which formula goes with which shape more easily. It's just a way of being organized. It's kind of fun to do that. So base times height, well, the base is x and the height is x minus 5. So therefore, the area is going to be x times x minus 5. And then we end up with a similar situation to what we were doing just with expressions earlier. We've just found a way to apply that math to geometry. I have to multiply across this bracket to get a simplified algebraic expression. X times x is x squared, and x times negative 5 is minus 5x. I have my area. I have an expression for the area. But then the perimeter of the rectangle is also going to be... Now, there's different ways of expressing that. I like this version of the formula, 2 times base plus height. So therefore, 2 times x plus x minus 5. Oh, now we have a set of parentheses where we can simplify something inside because there are 2 of the 3 terms in there are similar. So that is x plus x is 2x. And I can still multiply across this 2 across the parentheses. 2 times 2x is 4x. 2 times negative 5 is minus 10. We have 4x minus 10 as the simplified algebraic expression that gives the perimeter of this rectangle. We don't even know what x is, and yet we're still able to do geometry and other math, combining like terms type of math. With that, that's kind of cool that we can do that without even knowing what x is. But yes, we can also evaluate. So let's say this time I'm not just going to measure. I'm going to say this is more like a scale drawing. So I'll play around with that. This, I use a 12-inch side. So let's say x isn't 12 inches. Let's say x is 24 feet. Yeah, you can imagine that there would be a scale factor where this rectangle on my chalkboard wall could represent a big rectangle, like for instance someone's backyard that needs to be mowed, that could have a length of 24 feet. Sure. So therefore, x minus 5, x minus 5 would be 24 minus 5, which would be 19 feet. Oh, that's interesting. But let's stick with our algebraic expressions for now. If x is equal to 24, we have 24 squared minus 5 times 24. I think I need my calculator. 24, chalk dust. 24 squared, it's 576. Minus 5 times 24, I don't need the calculator from that. For that, 5 times 24 is 120. And then when I do my subtraction, I get 456. Yes, and of course that would be square feet because I said x was 24 feet. So I have the area, I can find the algebraic expression, first simplify it, and then I can plug in the values that I have. I can plug in the value I have for x. I didn't even need to plug in the 19 to do this because the x minus 5 gives me the 19 when I need it. Kind of cool. And then we have this, we have 4x minus 10, which is going to be 4 times 24, minus 10, which is 98 minus 10, which is therefore 88 feet. The perimeter of this rectangle would be 88 feet. The length of the fence that I would build around this yard before I mow it would be 88 feet. The area of grass I would have to mow would be 456 square feet. Cool, we can do that. It's fun too. Let's do the triangle. The triangle. There's a patch of sun coming in from the window, but it's not really affecting the video, so I'm not going to close the blind. Okay, let's do this triangle. The area of a triangle formula, area tri equals base times height over 2. And the base is 6 and the height is x plus 3, and the 2x is there for no reason, isn't it? Because we don't need that. We need a base and a height for the area of a triangle. We need the base to be perpendicular to the height. The 6 and the x plus 3 are perpendicular. We can tell that by our right angle symbol. So we're not using the 2x in this formula. So that therefore means we have 6 times x plus 3 over 2, which is 6x plus 18. I'm multiplying the 6 across the bracket over 2. And now I'm dividing the numerator. It's like it's a bracket because I'm dividing both of these terms by 2. 6x divided by 2 is 3x. and 18 divided by 2 is 9. 3x plus 9 ends up being our area for this triangle. And this is kind of a special triangle because when I do the perimeter, that's just going to be the three sides added together. So I'm not writing it as a formula. It's going to be the 6 plus the x plus 3. Oh yeah, that's why he put in the 2x. Because we need to know all three sides of the triangle if we want to find the perimeter. So I have 6 plus x plus 3 plus 2x. And then we get to apply our skills of combining like terms. We have x plus 2x, that's 3x. And we have 6 plus 3, that's 9. And hey, look what happened. 3x plus 9 is the perimeter and happens also to be the area. Does that always happen with triangles? No. It can happen with certain triangles that are just the right size, just the right shape. And I happen to have chosen a triangle where that happened just because I thought it was fun. Now, what if we find out what x is? Because I wanted to select this triangle where these two expressions would be equal to each other, the expression for the area and the expression for the perimeter, I actually selected a specific triangle. I knew what x was equal to before I made this drawing. And I know, and I can tell you, that x is equal to 5. Which means now I can evaluate the two expressions. Well, they're both going to give me the same answer. It's going to be 3 times 5 plus 9, which is 15 plus 9, which is 24. That's an area, so that is going to be 24. And I didn't say what the unit of measure was. It's going to be 24 units squared. I like to use the word unit as my unit when the question didn't give me a unit because it allows me to have something to put that little 2 on when I'm doing area. Useful thing to do. And this, of course, is 3x plus 9, which is also 3 times 5 plus 9, which is also 15 plus 9, which is also 24. It's just that the units are not going to be squared because it's a perimeter. It's not an area. Cool example. X had to be 5 for this to all work out. So we get to see this overlap between geometry that we were working on just a couple of weeks ago and this combining like terms and the pre-algebra skills that we're learning. All of these different types of math can be combined together in a creative way, and so long as you have all those tools in your toolbox, it doesn't matter. You're ready to deal with the math situation when different types of math are being combined. And how am I doing for time? I'm just about halfway through the lesson. Now, I'm going to do this lesson again with some students actually present. So, when I planned it, I was planning it for the usual hour, but right now I'm starting to think that this might be over before an hour, but I know what to do. Students are really good at coming up with interesting examples. So if I run out of examples and I still have some time, I'll ask the students. And that means you go ahead and make up your own examples, but wait until I finish all the ones on my sheet. I have that other side of the sheet that I was looking at by accident before. Turning it over, I have 7 examples on it. Let's see if 7 examples are enough to fill 31 and a half minutes of time. And now I can erase my triangle, my rectangle, and my square, and I have plenty of room because these expressions are very similar to the ones we were doing at the beginning of the lesson. It's just they're a little bigger, a little more challenging. So let's get into the first one. 6a squared, and yeah, I'm reminding you, we don't always have to use x as our variable. 6a squared plus 2a squared plus 4a plus 7 minus 20. Okay, so a little bit longer, but not really any more challenging. Same tools that we were using before are required from our toolbox. We have 2 terms that have a squared. We have only 1 term with a, and we have 2 terms that are just numbers. So we're going to combine the like terms. 6a squared plus 2a squared is 8a squared. The plus 4a, I just have to copy down. Plus 7 minus 20 combines to give me minus 13. This one already happens to be written in descending powers of a. Cool. And of course I want to remind you, when they get longer like this, it becomes useful to cross out things as you combine them. And oops, I didn't mean to cross that out. It's in the answer. Silly. Cross out things in the question as you use them, and it allows you a better chance to not accidentally forget one of the terms. With 5-term expression, it's kind of easy not to forget any of them, but as the expressions get longer, that can become more and more of a trick. Second one, I'm going to erase. And I'm not numbering these expressions. There's no point because I'm only writing one of them on the chalkboard at a time. 10m squared, yeah, I'm going to use m. 10m squared. When I use m, I have to be careful to write it neatly. Otherwise it looks like an n or an all sorts of other things. So I have to slow down. Plus 5m minus 3m squared plus 2m plus 6. Okay, let's analyze this. Again, we have two similar terms that have m squared. This time we have two similar terms that have m, and then we only have one term that is just a number. So that plus 6, I can predict right now, is going to be part of my answer. But none of the others are going to be part of my answer because I have to combine like terms, and it's going to change the sizes of them. 10m squared minus 3m squared gives me 7m squared. Cross them out. Plus 5m plus 2m, that's plus 7m. And then the plus 6 is the last one. And this one also happens to be written in descending order, descending powers of m. So that kind of happened by itself, but if it hadn't happened by itself, I could reorder it. Let's do a third example. Or if I don't have enough examples, I could challenge the dog to come up with one. Yeah, I know everything about algebra. I think I can take a nap during the lesson. Yeah, she's asleep. Looks really comfortable too. 8b squared, I'm using b. 8b squared. B is another letter. I have to be careful how I write it, otherwise it looks like a 6. Minus 4 plus 16b, 16b. Minus 8, and then we have bracket, b squared plus 2b, b squared plus 2b, close. Okay, so what do I do when I obey the order of operations? I realize that I can't combine anything yet, because this is a b squared, this is just a number, this is a b, this is also just a number, but I can't combine it with the 4 because this one's being multiplied by something. I have to do the multiplication before I can do addition or subtraction. And then I have parentheses, which I should do first, but again, they do not contain similar terms. So therefore they're in the parentheses just because both of them need to be multiplied by this, and it's an 8, but it's also a minus 8. Oof. So what I do is I just copy down all this stuff that I can't do anything with yet. And then minus 8 times b squared is minus 8b squared. That's one that's easy to see. But now we have minus 8 times positive 2b. Negative times a positive is a negative. 8 times 2b is 16b. Ha, did that. Now I can combine similar terms. Oh, 8b squared minus 8b squared. It's fun when something like this happens sometimes. 8b squared minus 8b squared cancels. We don't have a b squared term in our answer. And it doesn't mean they cancel into 1b squared. No, they cancel into 0b squared. They cancel into 0. And now let's look at these. Oh, plus 16b minus 16b also canceled. So there's no b terms in our answer. All we have left is this minus 4. That was a cool one. No need to reorder anything in this answer. Okay, I like that one. That was kind of fun. Next one. Let's use the letter A again. Negative 7a times 2a plus 3, close that, minus a squared times, 20a. So this bracket is only here to show a multiplication. This one is also only here to show a multiplication because the contents of it, there are two terms inside it, but they're not similar. So I have to do a multiplication and another multiplication, and I'm doing this one first because I got to it first reading left to right. Negative 7a times 2a is negative 14a squared. Negative 7a times positive 3 is negative 21a. Now this, I can do it right away because, well, I could just copy it down and do another line, but this time I don't have to. Negative times a positive gives a negative. A squared times 28 gives 20a cubed. And we end up with no similar terms. But we can reorder it in descending powers of a if we want, and I want to. So I'm writing negative 20a cubed minus 14a squared minus 21a. That's all I can do. Different. Kind of a different example. Basically, we get to the point where it doesn't matter what happens, all sorts of different little details happen, and it doesn't matter because we have the skills to deal with it. So, not intimidated by this. Next. That was the one with the A's. My next one also has A's. Okay. Write down another example. Maybe if I have time at the end, I'll try and put together a big challenger example. And then I'll answer it. 10 times 5a minus a. 10 times 5a minus a. That's not all of it though. Minus 16 plus 20. Minus 16 plus 20. Okay, I have to start here, and I do have similar terms. So I'm copying down the 10. I'm going to multiply it by the answer I get when I simplify this. 5a minus a is 4a. Minus 16 plus 20. Then 10 times 4a is 40a. Minus 16 plus 20. We do still have two similar terms, these two terms that do not have variables. Minus 16 plus 20 combines into positive 4. So we have 40a plus 4. Okay, fun. Next one, the letter P. Let's get the letter P. How am I doing for time? Yes, I'm going to create a challenger question, or maybe even two, because this is going so much faster than I expected. P, 12p multiplied by 3p minus p plus 6p squared minus 4. Okay, 3p minus p can be simplified. They're similar terms. So I'm copying down the 12p. I'm writing the answer inside this bracket. 3p minus p is 2p. Copy down the rest. 12 times 2 is 24, and p times p is p squared. And still we have the plus 6p squared minus 4. We have similar terms. We didn't look like we did before, but now we do because of that multiplication. 24p squared plus 6p squared is equal to 30p squared minus 4. Finished. No matter what we do, no matter what combination of weird stuff we try to put in this, we just have to apply our skills. Order of operations, adding and subtracting integers, multiplying integers, a little bit of understanding of exponents certainly does not hurt. And I only have one more example, and I'm going to use the letter X. Poor lonely X was sad because it wasn't being used in so many examples in a row. 6 examples in a row, actually. And we are starting with 8x. I'm multiplying that by 2x squared minus 5x squared. Close that. Plus 3 multiplied by 8a minus 2a. Oh, this one has a mixture of x's and a's. Can that happen? Yes, it can. Okay, so first thing I want to do is this set of parentheses, which do have similar terms inside them, 2x squared minus 5x squared gives me negative 3x squared. Next thing I want to do is this, and again we have similar terms inside. So I'm copying down all this stuff. 8a minus 2a is equal to 6a. Now we have a couple of multiplications. 8x times negative 3x squared. 8 times negative 3 is negative 24. X times x squared is x cubed. Plus 3 times 6a is 18a. 24, negative 24x cubed plus 18a. Perfectly good answer. Mixing in extra letters, no problem. So let's try to do something creative. A bit of the time that I still have. Let's put all of the operations that are mentioned in the order of operations in here. So I'm going to try to make kind of a big long question. How about there? That's just a start. I'll use this multiplication symbol. What this is turning into is described with mathematical terminology as a big mess, because I'm making up a big complicated question, kind of randomly selecting things, so it might turn into a big mess. There. Okay, I have parentheses, I have an exponent. I have a big division. This big giant fraction line represents a big division. I have multiplications. I have addition and subtraction. That division could end up being problematic. So what I'm going to do I don't think I'm really solving this problem. So I'm going to end up with a complicated answer is what's going to happen, because I think I've had enough. I want to do this. I want to get into, and I also might have difficulty having room for the answer. 2x plus 3a minus 7 plus 8x. I want to deal with that first, because there's that reading left to right thing. What about this up down stuff? Well, if we want to read it in order, we would start here, get all the way to the end of that line, and then say divided by, and then continue over here. So that's still reading from left to right. So top to bottom, left to right. 2x plus 3a minus 7 plus 8x gives me, the 2x plus 8x is 10x. And then I just have to have the plus 3a minus 7. I also put all of that in a bracket, and I don't really need it in a bracket, because there's nothing being multiplied by it. There's no negative sign before it. So 10x plus 3a minus 7, not so bad. Then this one, oh, I can't get rid of the bracket yet because there's a multiplication in there. 3a squared times 4 is 12a squared. Okay, so that's all I've done in the top so far. and I have to take away this bracket. It is a big mess. It's just going to be a big mess. There's not going to be much in the way of a clean, small, simple answer here. 2 times x plus x. Oh, that's 2 times 2x though. I'm combining these two like terms inside this bracket. And over here we also have like terms. 3a cubed minus 2a cubed is a cubed. I don't really need the bracket. I'll keep the bracket for now. Oh, no. 3a cubed minus 2a squared. No, I'm wrong. I wasn't following my own rules. These are not like terms. It looked for a second to me like they were. That's a cubed, that's a squared. So basically this is only here so I can take away the bracket. And minus 3a cubed is not confusing, but be careful. Minus negative 2a squared means plus 2a squared. And then we have this plus 7a is all squared. So that means I have to do 7 squared, which is 49, and a squared, which is a squared. I have plus 49a squared, but then after it I have minus 49a squared. And I have to make this line longer. I'm going to run out of room. Okay. 10x plus 3a minus 7. All I can do now is take away the bracket and adjust the signs. Minus 2x squared minus 12a squared. That's my numerator. The denominator was looking pretty crazy, but this kind of helps. Plus 49a squared minus 49a squared cancels. I still have to do 2 times 2x, which is 4x. And I still have minus 3a squared and plus 2a squared. And I cannot simplify anything else here. There are no similar terms in the numerator. There are no similar terms in the denominator. The division of this big 5-term polynomial by this 3-term polynomial, we're not doing that. So that's a big mess. It started off as a big mess, it ended as a big mess, but it was a bigger mess when it started. I guess that's the real take-home message of this little particular example. What else can I do? I can evaluate. I have a bit of time, so I can evaluate. Let's evaluate. Now this thing about evaluating, we talked about it last week. That's when you find out what the a is equal to and what the x is equal to, and you substitute those in and you're able to turn in the answer into a number. If we tried to do that with this, we would succeed, but it would take a really long time. If we knew a was, well, I'll decide what a and x are equal to right now. Let's say a is equal to 3 and x is equal to negative 2. Haha. So I can replace every a with 3 and every x with negative 2 in this original expression, and if I'm careful, I would be able to, while following the order of operations, evaluate the whole thing and get an answer. It would be the correct answer. But why would I do that when I can simplify first? So even though this is not especially simple looking, it's a lot simpler than this. So I want to plug the a equals 3 and the x equals negative 2 into this expression. And to do that, I need some space. So what I'm going to do now is I'm going to erase the original question and this intermediate step. But I'm keeping this simplified version, and now I can copy this up here, but I'm going to replace all the a's with 3's and all the x's with negative 2's. So we have 10 times negative 2 plus 3 times 3 minus 7 minus 2 times negative 2 squared minus 12 times 3 squared. Still a lot of simplification to do. 4x is going to be 4 times negative 2. Minus 3a squared is minus 3 times 3 squared. And plus 2a squared is plus 2 times 3 squared. Suddenly we have a lot of exponents we want to simplify. But we also have multiplication, there's subtraction, there's a bunch of stuff to do. I want to do all the exponents, so I'm just going to write 10 times negative 2 plus 3 times 3 minus 7 minus 2 times, now this, I have to be careful how I wrote that, negative 2 squared. Yeah, you have to write it kind of like this, because of the negative sign. It's negative 2 that's being squared. We have to do negative 2 times negative 2. without that bracket, it looked like it was just negative 2 squared. The order of operations would make us do 2 squared and get 4. We'd end up with a negative 4. We're not going to end up with a negative 4 because we want to square a negative number, which means negative times negative equals positive. Glad I noticed that. Okay, so inside that bracket we have negative 2 squared, which is positive 4. There. Minus 12. That's the only time that's happening though. Minus 12 times 3 squared, which is 9. Interesting. Then we have 4 times negative 2. I don't want to do it yet because I want to respect that order of operations. Because I have 3 squared here. I have minus 3 times 3 squared, which is 9. And I have this 3 squared plus 2 times 3 squared, which is 9. Okay, I'm running out of room, but this is getting, notice how this big giant thing gets smaller and smaller as you do the steps. A whole lot of multiplications. 1, 2, 3, 4, 5, 6, 7 multiplications. Nearly everything in this needs a multiplication. It's just this little minus 7 I can't do yet. 10 times negative 2 is negative 20. Plus 3 times 3, which is 9, minus 7. Minus 2 times 4, which is minus 8. Minus 12 times 9, which is minus 108. Over 4 times negative 2, which is negative 8. Minus 3 times 9, 3 times, that's minus 27. Plus 2 times 9, which is plus 18. Now I'm going to go over here so I don't have to erase this. And I'm just combining everything in the numerator and then combining everything in the denominator. Negative 20 plus 9 is negative 11. Minus 7 is negative 18. Minus another 8 is negative 26. Minus another 108 is negative 134. I might have to grab my calculator and double check that. I'm asking for trouble with so much stuff. Negative 8 minus 27 is negative 35, and negative 35 plus 18 is going to be negative 17. I am checking out the calculator, both the numerator and the denominator at this point. Negative 20 plus 9 minus 7 minus 8 minus 108. Yes, it's negative 134, and then negative 8 minus 27 plus 18 equals negative 17. This almost looks like it could divide nicely, but it's not going to. Negative 134 divided by negative 17 gives me a decimal. The negatives cancel. Negative divided by negative equals a positive. So my answer is positive. And it is 7.8823, etc. I'm going to say positive 7.88. Rounding it to the nearest hundredth, I was able to evaluate that expression. I'm certain evaluating this mess was easier than evaluating the original big giant mess that we started with. But I can approach it with confidence because I have practiced all of these tricks that we've been working on the past couple of weeks. And I've practiced them a lot, and I have confidence in them. All these little things, all the order of operations, all of the skills of combining like terms, all of my knowledge of exponents, that was a tricky one. That's worthwhile to do a little example just of that. And since I still have a tiny bit of time, I'm going to. Okay, this idea of a negative being squared, depending on where the brackets are. It's a worthwhile thing. Although I didn't intend to insert it into this lesson, I kind of did it by accident. But now that I've opened that can of worms, I'm going to pull out a couple of the worms and look really closely at them. Okay, so negative, I'll use, instead of using negative 2, I'm going to use, say, negative 5. So we can have negative 5 squared. Or we could have negative 5 squared. The bracket is forcing us to say negative 5 times negative 5. This is equal to negative 5 times negative 5, which is giving us positive 25. But this one, there's no bracket. There's no parentheses. So the first thing I have to do is the exponent. The E for exponent happens before the M for multiplication. And you might be saying, wait, what multiplication? Minus. A minus sign is like multiplying by negative 1. But again, we don't multiply until we do the exponent. So the 5 squared is going to, I'm going to have a negative sign, and then 5 squared is 25. Therefore, I have negative 25. This one gives me negative 25, and this one that looks so similar gives me positive 25. I have taught this many times, and I know that this is a little tripping point for students at times, where you have to be careful when you're applying exponents with integers, with negative numbers, that the student has to be careful to notice whether there's a bracket there and to follow the order of operations accordingly. But the teacher who's making up the question also has to be careful, because sometimes we write it down too fast and we forget to put a bracket that we should have put, or we insert a bracket that we didn't really mean to put there, and it causes our negative answer to be positive or vice versa, and that can turn into, what is it we call that in math again? Oh, yeah, that can turn into a big mess. Okay, so little Miss Show Off, who still hasn't reached for the chalk even once, even though I dared her to 56 minutes ago. She's still looking there, lying there, looking really comfortable, just looking at me. Only her eyes are moving. Very cute, but she also knows that it's supper time, and she's just waiting. She's very calm. She's just lying there like a dust mop. That's what she looks like, really. A little chocolate brown dust mop. She's just lying there. But as soon as I tell her, okay, I'm going to show you to the camera and say goodbye to the students, then she's going to know it's supper time. And then when I put her down, she's going to do her tap dancer routine, which you might be able to hear. We'll see. I'll try to be quiet, and we'll see what it sounds like. Don't disappoint us, Mocha. Okay, up, come on, up. I don't want to drop you. Okay, say goodbye. Wave goodbye. Look at the camera. Look at the people that you're waving goodbye to. Thank you. Thank you. Okay, so it is supper time. It's time to eat. And you're lucky I didn't make you teach, because I think you would have embarrassed yourself. Her communication skills are really not up to par. I don't think she's going to get a job as a teacher anytime soon. Okay, so it's time to go. There we go. She's doing the stretching thing. I was expecting her to start bouncing around. And as soon as I turn off the camera, that's what she's going to do. Disappointed. Okay, anyway, this has been fun. Oh, there comes some noise. This has been fun. As usual, it's fun. As usual, the hour flies by faster than I expect. Thank you very much, and I will see you next time.